Okay, we're starting off with notes right away. But I want to explain a few things that we went through some changes while you were gone. And it made some adjustments. And I'm going to show you those adjustments here. Let's start by looking at the YouTube.
Wait, I missed you.
Oh, I missed you too. I had to go over your names again in my sleep last night. Now, if you notice on the YouTube, the big thing now is the videos are optional. Everybody learns differently, and you have to start understanding the best way to maximize your learning in my class. Part of that is staying focused. Now, because I watched what you were doing after we split, and I could tell that some of you continue to watch the videos even into 9. But what's the point of watching the videos if Mr. Bertucci is going to give you the lesson? So I can see why it tailed off then, as we went into 10 and then 11. And then I was told not to have it be required, so it wasn't required. But still, here and there, people are catching videos. And notice also now there's this thing called live where I tape what you're doing so I get your questions as well. This gives you a great variety of how you can use all these resources. Right? But be assured that we will have a lecturing class every day. And it'll take anywhere from 10 to 30, 40 minutes, depending on the nature of the material. And you'll have time to work on your homework toward the end. Plus, if you liked watching the videos and watch it at your own time, you can go ahead then and start working on your homework in class. Because it's hard to sit there and try to watch the videos at home and do homework and then come to class and watch me do it too. So, this is what I kind of proposed after your comments in September and October. Remember that diagram where we had some kids sitting up here, some kids kind of middle, some kids toward the back because they had gotten their work on it. Well, nobody wanted to look like they were the kids that didn't get it right. And I can understand that. That's why you are free to work on your homework during the lesson if you feel you got it. If you don't feel you got it, or you just didn't watch the video first, that's where we're going to start with the video. And it will be taped, so people like Emily now have a choice. They can either watch the video I made ahead of time, or they can watch the video we did in class. So you have a lot of choices there. Here's your other source of choices, and let me show you that on the Flange Wiki space. Here we go. Notice, let's just look at chapter 13 now. Hopefully you got the green syllabus for Mr. Bertucci. Okay, they look like this. Make sure you understand all of these things. Here we go. That's the syllabus, in case you lose it. You can always print it up. Here's the sign-up sheet, and we'll do that after we get through the lesson today. You can sign up for some problems. You get to first dibs because you didn't have any chances in the third quarter. Now, notice 13.1 comes in a variety of things here. First of all, 13.1 blank. This is basically a nice way to do your notes. You can, and they've done this a lot in the other class, where they print up this, and it's got a lot of the verbiage there, so you don't have to copy that down, but you can focus on going through the process of solving problems. So it saves you that time in class of having to write down what the question was. The question's right there.
So that's like,
and it's not just blank. Sometimes it's full of blanks, but mostly it's like, I give you the details for the question, you can focus on ideas on how to solve it.
so that's like the PowerPoint or whatever it is that you use to record the videos in?
Yes, because then, and see, so that's optional, because some of you are eco-minded, right? And you feel you don't need that, you'd rather just take notes the standard way, that's fine. That's why I don't print it up for everybody. Here, 2012 PDF, this is what I do when I do the pre-recorded video. And so this has got the answers in it. This is what we did in Group 1 today. We started with a blank. And I know how sometimes you're irritated when I kind of sponge off of Group 1. So we'll start with a blank slate again, and there'll be one for your class called Group 4. Right? So you got all sorts of different sources of how you can get the notes, if you can get them, or how you want to use the resources.
Wait, are our pips carrying over from second quarter?
Yes. Well, at half rate, okay? So some of you did have quite a few pips.
What did we do with
Congratulations. You and Alex had significant amounts of pips carried over.
Yeah.
Okay. So. Now, the other thing here is HW. Remember I used to put the homework at the end of each of these? I thought it might be easier if I just made a separate file now. And both classes will be contributing to that, so if you want to look for homework solutions, right there. All right? That's another thing you do in class is making your pretty solution for the one that you're going to give me. You were a little stressed out before because the other class was trying to do all the solutions. Well, we didn't really.
How did we do the PIPs notice if we did sheet?
He had another system. He did homework checks, right?
Yeah.
And that probably had a nice impact on your grade, right?
Yeah.
Because you're a homework doer,
Oh, yes,
not a homework watcher. Okay. All right. So I think we're ready to begin then. I just want to kind of get you up to speed where it is for that. And I'm very much interested in your comments at the end of the year about which one of these vehicles worked best for you. It might not be the same thing as the person next to you, right? But it's important to keep looking for ways to maximize your money. Okay? Yes.
Are we still going to have practice tests like we did last quarter?
Yeah,
Yes, they're posted. Air Force Generals only, right?
those are from Plan. The ones that Virginia gave us are from Plan.
Yeah. They're over here. You want to see where those are? It's on the side here. Sometimes it's a little hidden. Maybe I should move it up there. There's top secret. Air Force Generals only. Notice last year's test. You may prepare for this year's test. And PCH is first there. So yeah, there are the solutions. Yeah, I've got actually the PCH. There's the practice test. The solution's already in there for the rest of the year. I will be adding in the actual practice test itself into here as well. What I usually do is I print up a hard copy of that. Okay? And I'll get that to you as we get more into the chapter. Now, notice how this is listed as two separate tests, but because of the time crunch, we're going to have to combine that. So on the green sheet, I showed you that we do have a combined test on 17 and 18 as well. And this is kind of nice because the combined test on 15 and 16 is sort of the stuff. Did anybody sign for AP Stats?
Yeah.
AP Stats next year. This is giving you an idea what's going on in AP Stats next year. And it's a good foundation for that. Then 17 and 18, we don't use the 17 and 18 book. It's some packets we came up with. That gives you the foundation what you're going to do in either AB or BC count next year. Now, the third quarter review pack has a special schedule. It's basically for how many weeks you do it in advance. So if you give it to me that first Friday after spring break, you can get 4 points. Okay, and so forth.
You get over 100.
Yeah. I'm not giving it over 100. That over 100 just can go into pips. What's the other thing? Oh, now you also have that regain and retain. Nobody gave it to me in the third quarter. They usually don't. If you got less than an 80 on the first semester exam, you must do it. Everybody else may do it, and then only count it if it improves your fourth quarter.
Wait, where
I have no idea where that is.
I passed those out, the regain and retain packets, big R&R.
You got it?
And again, that's also
Even if
on the
you
wiki
have
stage.
it.
You lost your copy. Okay? All right. Uh-oh, I don't know what it is there, but
Is it
something's
on
got
Brian
saved.
too? Are like the third quarter review pack and the regain and retain, are they both online?
Yes.
That is. The quarter one we have not managed.
What?
Okay.
We have not the third quarter one.
Let's get into the lesson here. And some of you have seen the Algebra 2 honors, but we do a quick summary of this. Arithmetic and geometric sequences, you're going to try and find the formula for the nth term. These are some examples of arithmetic sequence. What's the scoop here? What are we doing?
Adding 4.
You keep on adding 4.
What's Pancho?
Plus contra.
Sam, kangaroos.
What you?
So what's the common difference?
4.
4. Not negative 4. Positive 4. Positive common difference gives us a sense of an increasing sequence. Negative common difference is decreasing. Here the common difference is negative 4 minus 3 and negative 7. Any two successive terms if you subtract them. But notice the direction of the subtraction is important. You take the term to the right minus the term just to the left of it. Okay? All right. Get the idea? Now what I can do is this. Let's split the screen. So, geometric sequences, on the other hand, a common ratio. What's in this case? 1/3 or 3/4? The vernacular,
3.
3. I will mark that off if you don't reduce that. I am that picky. And it keeps being 3, right? Common ratio here?
Negative 2.
Negative 2. 64 over negative 32 is negative 2. And the common ratio usually is R for that. The ratio of 2 consecutive terms. But it's always T sub n plus 1 over T sub n. Just like the common difference is T sub n plus 1 minus T sub n. You like to say sub a lot to point to where we are in the sequence? Sean?
Shouldn't the second one be 1, negative 1/2?
Yeah! Thank you, Sean. Oh my gosh.
Sean.
Let's get that fixed. Here we go. Negative 32 over 64, negative 1/2. There you go. Notice now you have a negative sequence, and a negative common ratio will make it alternate the sign. If you have a positive common ratio, keep the same sign. But with arithmetic sequences, if you have a negative common difference, it will switch at some point and then stay switched. Same thing with positive common. Now here's one that's neither, right? T sub n equals n squared plus 1. We get 1 squared plus 1, so that's 2. 2 squared plus 1, 5. 3 squared plus 1, 10. 4 squared plus 1, 17. Does it look arithmetic?
No.
3.
If you take the difference of the difference.
And that makes all the difference. The differences in the differences stay constant. Are you sure? I'm not so sure. Let's try 5. Let's get T sub 5. You get a little extra in this class. Okay. 26. That's up 9er. There you go. The difference in the differences again is 2. So with this being constant, that means it's a quadratic variety. If the differences are constant, it's an arithmetic sequence, basically a line. But if the differences in the differences, then it's quadratic. And then if you have to go to a third level of differences, then it's cubic. We don't do too much with that just yet. Now remember, this is very important. T sub n is the nth term. It is the actual value of the nth term. It's the output of this sequence function. N is the index. It's pointing to where you are in the sequence. It is not the value of the term. So the fifth term here is not 5. The fifth term is 26. T sub 5 equals 26. Okay? Now there's the formulas for the arithmetic sequences. See, now this is nice. If you had this printed up at the time, you can just draw the arrows here. You want that a little bigger, don't you? Maybe a little twisted. There you go. Bigger and twisted. There we go. So to find the nth term, you start with the first term.
They're at different angles. Oh, no.
Will that be okay?
No,
There.
that is
The angles form an arithmetic sequence, okay?
The angles are at different angles.
To get to the nth term, you start with the first term and add the common difference n minus 1 times. This is what freaks kids out, this n minus 1. Why isn't it just like the old days? Y equals mx plus b. Very simple for a line, right? And we'll talk about that. Try to figure it out later. Why does this have to have the n minus 1? Any insights right now?
Minus y, it's n minus 1.
Yeah. So just add.
Don't you need to get to like the
Oh,
previous
because you're adding the first term already, so you don't want to add it twice.
You're already at the first term.
Right.
And to get from the first term to the second term, how many common differences are you going to add?
one,
1, not 2.
Like you don't want to have.
So the common difference is associated with a comma in between the terms. So to get from the first term to the third term, it's going to go T sub 1, comma T2, comma T3. That's 2 commas. That's 2 common differences. So to go from T1 to T3, we only want to add the common difference twice. You look so puzzled, some of you back there. There's our sequence. It goes T1, T1 plus D, T1 plus 2D. See how the multiplier and the common difference is 1 less than the index. Okay? Alright. Okay with that formula? Now, notice the matching of the 1 and 1 there. That's another way to see this. Why do I say n minus 1? Because you're going from the first term to the nth term. So this formula is actually kind of handy. To get to the nth term, you could start with the kth term. And then add the common difference, n minus k times.
Wait, what is
Instead of
K?
n minus 1 times. K is another index. It points somewhere else in the sequence. See how this is consistent with this formula for like k equal 1. And what if k equals 0?
Isn't that just the same formula but subbing
Maybe
A
T
Right, and for 1. If k equals 0, you can say t sub n equals t sub 0 plus n minus 0 times d, or t sub n equals b plus nd. Now it's starting to look like y equals mx plus b. And that's why y equals mx plus b is simpler. When you did a line, b represents what?
The y-intercept.
The y-intercept, where x equals 0. So x in y equals mx plus b, our input is x, output's y. But we usually have any real number go in there, right? With sequences, we're very particular about what goes in for n. What can you use for an index? Positive integers, called the natural numbers of the positive integers. Now, actually, you will see some people try and get by with using a naught or a 0 for the first term in the sequence. We call it the 0th term, the first term. And we're actually going to do that too when we expand out binomials with a binomial pair. But for now, for all your homework, we're just start with 1. The first term as an index of 1. And
So you would use this second formula if you didn't know what the first term was, but you had some other random part of the sequence.
like you're given the 18th and the 21st term. That would be handy in that case.
What would you be looking for then?
So you can still find D. We're going to do that. In fact, that's what we're going to do with this next part here. Solve this formula for D. Let's make it a little bit. Here, see it back there. Boom. Okay. Solve this formula for D.
T sub n minus T sub a over n minus k.
Well, let's just take a few steps here before you lose the crowd. T sub n minus T sub k over n minus k, right? And what does that look like? Right? Slope. Looks like slope. Change in y over change in x. Change in the output variable over change in the input variable. In fact, this is a big idea when we get to the derivative in math. The difference quotient, the division of two differences. You've known all along the lines as slope. Okay. The geometric sequence is similar, but now you crank everything up a notch. And it's called geometric, even though it looks like it's exponential. We'll get to that in a bit here. To get to the nth term, start with the first term and multiply by the common ratio n minus 1 time. Can you see those okay?
Now you have to make them bigger and tilt them.
Oh gosh. No, I've done it.
Oh no, it's off. How you done it?
It'll be okay. It'll be okay. It's a little stubborn. One doesn't tilt that way. There we go. Make that one a little bigger.
Okay, you tell us.
Ooh, tilting. Come on,
There you go. Now it's all in the right
Now
spot.
heading.
To get to the nth term, start with the first term and multiply by the common ratio that many times, n minus 1 times. Okay? So, find a formula for the nth term of this arithmetic sequence. T sub n, T sub 1 plus n minus 1 times d. Let's start with the formula. Take an AP stats, you gotta get used to this idea. Jot down the formula, show your substitutions. 3, 2. Common difference is 2. 5 minus 3 is 2. I don't have to keep checking because I was told it was an arithmetic sequence, so I can take any. Now, it's considered polite to expand this out. 2n plus 1. T sub n equals 2n plus 1. There's a formula for the nth term. Oh, it's graphic. Notice on your axes now, though. Hold it. What do you label this this axis? N. The index is N. And this is T sub N, the value of the term. So 1 goes to 3. And 2 goes to 5. And 3 goes to 7. And 4 goes to 9. And 5 goes to 11. And you can see, we don't have a line. It's a sequence of dots that are all in a line.
Oh, don't you have to do the thing with the lines next to them then?
Fill it in.
No, I thought you had to have like a... I thought there was, you could put a line like going across the end with an open line at the 2. Or an open circle at the 2. So it's like a stair step for a dot.
No, you're thinking of the greatest integer function.
Oh, yeah.
Notice where this collides down here at 1. And if we were graphing the line, we'd start with the y intercept at 1 and keep going over 1 up 2. The line would include, it would be a solid line because it would include all the real numbers as its input. The difference with the sequence is our input is just the odd and pointers. That's where you have a subset of a line. But it still tells a lot of the same ideas. Find a formula for the nth term of this geometric sequence.
Write down the formula.
Yeah. Is it remembered?
T sub n equals T sub 1 times r to the n minus 1.
Okay. So you get 3 times r. Oh, let's figure out r here. 4.5 over 3. 1.5. You like that? How about the variant 4.5 to the n minus 1?
No, it's not right.
What do you mean?
You have to do the n minus 1 before you multiply.
Exactly. This is Galbi. Let's get out our Galbi stick.
Smiley faces.
Yeah.
Can't do that. It works. It works. We're going to say 3. I would accept this. But sometimes it might help if you write it as 3 times 1.5 to the n over 1.5 like that to the first. And so you get 2 times 1.5 to the n. I would accept that too. What? I'm using the rules of exponents. The n minus 1 power, x to the a minus b is x to the a over x to the b. 1.5 to the n over 1.5 to the first. The point is to get this kind of meshed in with your constant term. So that would be legal. And we can see how it's going to show up in our graph next. Again, let's label this up as, this is T sub n, this is n, and 1 went to 3, and 2 goes to 4.5. So if it was arithmetic, 3 should go to 6, but no, it goes up to 6.75. So you don't have a common difference there, you have a common ratio.
Why do we have 2 formulas for D? We have D equals T sub n plus 1 minus T sub n,
Yes.
and then D equals T sub n minus T sub k over n minus k.
Right.
Oh, that's only when you don't know the first term?
Let's go back there for a second. Hang on. You question my formula.
No, I don't.
T sub n equals T sub n minus 1 plus t, right?
What? No.
And, well, that's one of the ones you told me. You can find the common difference. You can find the common difference by doing T sub n minus T sub n minus 1, right?
No, T sub n minus T sub n plus 1 minus the first. I suppose that.
Okay, fine. Okay, it's very similar, okay? Now, this is consistent with this formula over here because we can say D equals T sub n minus T sub n minus 1 over n minus the quantity n minus 1. And notice you just get 1 underneath. Okay? So you still get T sub n minus T sub n minus 1 all over 1. So it's a special case of this more general idea of slope. Okay? I like that question. Okay. Now, where would this cross the T sub n axis? technically it doesn't if we're going to talk about a sequence with a first term. But its zeroth term would be what? 2. And that's actually indicated by this format. This is what you talked before, a times b to the x power when you did exponentials. So you could put a 2 in there and go, whoosh, exponential. Well, if this is exponential, why is it called an exponential sequence? Why is it called geometric?
Because geometry.
Because of geometry. Let's look at this right triangle. Remember the right triangle?
Yeah.
And the altitude and the hypotenuse? And then maybe keep doing that?
Oh. It's crazy.
And they form. Oh dear. Will we ever get there?
Let's keep going.
Finished. These hypotenuses form a geometric series. Okay? Because you can set the proportional sides of the triangles and so forth. You don't believe me! This is an A by B, right? Let's just call this H. Take it from there, come on. Give me this next one now. What's this going to be?
B divided by 2.
They all have the common angle up here. So B is to A as, so this, let's say long side is to short side as.
Oh, they're both going to be choose to.
B is the hypotenuse, so H is to that weird section.
We want to see this nice little section in here, right? We want to see this?
That's
Half to b squared plus a squared. Remember, it was
Whatever this is over here, we have a D, right? As D is to H.
yeah.
And then you can do some other substitutions. That's a nice extra credit opportunity, okay, to show that these form the geometric series. Sequence. So in a geometric sequence, we've got these two numbers. T sub 3 equals 12 and T sub 6 equals 96. Find T sub 11. So let's translate both these ideas. T sub 3 equals 12. And plug it into the T sub 3 equals, remember T sub n equals T sub 1 times r to the n minus 1. We don't know T sub 1 and we don't know r. Ouch. So T sub 3 equals T sub 1 times r to the 3 minus 1. T sub 3 is 12. Right? It's kind of like saying f of 3. T sub 3 is 12. We don't know T sub 1. I know r squared. Ouch. One equation, two unknowns.
One more equation. Use that on.
We need more data. T sub 6 equals 96. So T sub 6 equals T sub 1 r to the 6 minus 1. Or 96 equals T sub 1 r to the 5th. Now we have two equations. Two equations in two unknowns.
Let's divide both by 12.
No. No, you mean 7.
Well, you can do many things.
Wait, divide r squared r.
You can divide it all.
No. Times divide.
96 equals, first of all, write it bigger. Get on a big dividing bar. Something huge. And divide it by the other equation, 12 equals T sub 1 times r squared. Can you do that? Can you divide whole equations? Yes, you can. You did it all the time in linear combination. You would adjust one equation, then add up to the left sides and add up the right sides, and it's still equal. Same thing here, as long as we're not dividing by 0. So we've got 8 equals the T sub 1's canceled.
Wait, why can you?
Why can I which way?
Why can't you just divide it like that?
Because they're both true. A equals B and C equals D.
But do they have?
So A divided by C equals B divided by D.
Do they? You just. I don't think they have any like relation to each other.
They're both true.
Could you set them both equals?
You want to set them both equal to T1 and then solve. You can do that, right?
Okay.
I just think that's a little more time than just plain old dividing
That's
out.
what I thought you did.
Leisure wins in assembly.
Academy is all your butts.
Your family don't have that.
Lackluster house.
Hold it. R equals 2. We're not done.
Hey, right?
find R, it said find T sub 11. We still need T sub 1 yet, right? So, if 12 equals T sub 1 times R squared, now we have R equals 2. We get T sub 1 equals 3. So now we've got T sub n equals 3 times 2 to the n minus 1. Or in the vernacular, right?
No, sir, that's not right.
No, sir, good. You still don't like that. That's good. That's good. That would be one big chunk of flowery, happy junk. Junk. You can't multiply that 3 times 2 because you don't know the power. Still, look at that. It didn't say find the equation. It said in terms of, it said find T sub 11. So now we can say, okay, T sub 11 is 3 times 2 to the 11 minus 1. 3 times 2 to the 10. That's in your, oh, I know that one, Mr. Lang. That's in the first 10 powers of 2. Which is 3,072. Unlike the video which said 3,076. Okay? You should have seen the answer was right there the whole time.
It's a presidential election.
It's a trial.
No, we're going to move on. But easier way, could you say T sub n equals T sub k times r to the n minus k? In which case, r would equal the n minus kth root of T sub n over T sub k. Memo if you like it. So if you want to add to your repertoire, in this case it would save you setting up a system of equations, right? So you get r equals the, what was it?
11.
No. Remember your given information was T sub 3, right?
Yeah.
Equal 12?
Yeah.
And T sub 5.
6.
6 equals 96. So now you go, the 5 minus third root of 96 over 12, 6 minus third root, or the cube root of 8, and you get it like that. And I think you ran into this too in QCP honors. Do you memorize just all the base equations constantly derived from the thing and set up systems, or do you memorize more equations and then substitute in? So it's just kind of up to your personal preference if you want to also memorize it. Okay? Again, we're still not there. We still have to go ahead. But now, here's the other thing too, is we don't need to know T sub 1. We can say T sub 11 is T sub 6, where we left off, times r to the 11 minus 6. Or T sub 6, which is 96, times r, which is 2 to the 5th. 96 times 32. Well, just double this thing 5 times and get 37 inches, right? Okay. That's it. Now we have time to sign up for homework problems. Oh, and also I'm going to pass out these bad boys. Mr. B will be transferring me your test soon, and I'll give those back to you. No, I don't have them. How can I get them?
You should put them on my lecture.
Okay. Hang on. Stop.